Hello everyone and welcome. I'm Arnav, a final year student. Today I'll introduce you to our project Pi-hole system that blocks and adds a tracker across your entire network. I developed this with the help of my teammates Vivek, Yuraj, Ritika, Mehak, Ashmit, Shrutika and Shreyash. Pi-hole act as a DNS sinkhole. When a device on your network requests a website, Pi-hole checks if the request is for a ad or a tracker. If it's if it is, Pi-hole blocks it. If it's not, it will allow the request to proceed. This process enhances the privacy and speed up the browsing by eliminating unwanted content. As shown over here, the block domains. The top block domains in our network was the Netflix, Amazon, and the Microsoft and LG. The top allowed domains is the NTP server, again NTP server, again NTP server, and the Netflix, Cisco, and the multiple domains. Here how Pi-hole operates. Device sends a device sends a request to Pi-hole. Pi-hole checks the request against its block list. If the request is for an ad or a tracker, Pi-hole returns a blank response, preventing content from loading. If the request is legitimate, Pi-hole forward it to internet and connect loads usually. As shown over here, the DNS Pi-hole. If it's not an ad, STT or HTTPS, it will load normally. If it's an ad, it will check over block list and it will block the ad. Or if it's a HTTPS, it will give a timeout request. This setup ensures all the device on your network benefits from ad and the tracker blocking. To manage our Pi-hole setup efficiently, we utilize Proxmox virtualization environment. Proxmox VE is an open source platform that contributes the KMV kernel based virtualization machine for full virtualization and LXC container for lightweight containerization. This contributes allow us to run multiple virtual machines and containers on a single physical server, optimizing resources use and simplifying the management. We install Pi-hole on the virtual machines with the Proxmox, ensuring easy maintenance and scalability. This is the Ubuntu 20 running the Pi-hole inside it. Its resources having 6 GB of RAM and the 40 GB of storage and 4 cores. Pi-hole provides user-friendly web-based XSS at its static IP. Query logs monitor real-time DNS queries, see which domains being accessed. Block customize and update list, block unwanted content. Whitelist or blacklist. Add or remove domains to control access. Statistics. View graphical representation of block queries to top domains and the client's activity. This feature makes it easy to manage and monitor the network traffic. Implementing Pi-hole offers the several advantages. Improving browsing speed by blocking ads and trackers, web page or loading fast. As shown over here, we have we have added 74 lakhs of ad blocking list. Out of that, the 100 out of 14 clients, 100,000 request has been forwarded. Out of 100,000, 33,000 request has been blocked over the Pi-hole. Total number of clients were shown over here. So 14 clients are connected in this network. Reduce the bandwidth, less data, and consumed by block unnecessary content. Over here, we can disable or enable the ad blocking. If the particular website was blocking by the Pi-hole, we can temporarily or permanently disable it. Over here, we are using Google DNS, OpenDNS, and Cloudflare DNS, whichever responds faster over the network. We can also use the Pi-hole as a DHCP server, but as of now, we are not using in this network-wide protection. All the devices connected to your network are protected without the need of individual configuration. Our setup involves installing the Pi-hole on virtual machines with the Proxmox, configuring a router to use Pi-hole as a primary DNS. In the router, we can set as the primary DNS as this IP. All requests will go through this IP, then only the client will get their request done. Monitoring and managing the setup through the Pi-hole dashboard. We successfully block a significant percentage of ads and trackers, improving network performance and user experience. The valuable significance into the network pattern. Over here, we can see the diagnostic. If any block list has not responding an inbound or outbound request, it will show over here. We can also audit it by checking which domain is blocking mostly, and we can whitelist over here or block list. Over here, we can see active block domains and going permitted domains. By this NTP server was blocked by the Pi-hole, and most of the requests are going for the NTP server only. As checking, the top requested client were Pi-hole because of Pi-hole is only requesting the request from the internet. That's why it's showing the Pi-hole as most. The initial configuration setting the Pi-hole on a Proxmox required careful planning and network capability, ensuring all the devices on the network use the Pi-hole as their DNS server. Performing monitoring and keeping track of the Pi-hole performs and resources uses. Future planning for our project includes integrating a VPN to allow securely accessing to Pi-hole from the outside network local. In the future, we are planning to add a T-scale network, a robust and free to use VPN solution that's not required a public IP. Developing a mobile application for the easier maintenance and monitoring. In the future, we are also planning to integrate this into the mobile application to ease of use and the more one view. Exploring machine learning to dynamically update the block list based on the image. Currently, we have to manually update the block list. We are planning to add the automation tool to add the block list every day, whichever the new ad list will add. Thank you for your attention. This project has been valuable for learning and experience in the networking and virtualization and the system administration. I'm happy to answer any question you have.